Looking at the wheel, it didn't make it into the bill of materials, which is kind of strange. So we can fly over. Oops, that wasn't it. Alright, so let's bring it back down. The wheel bracket, wheel support arm, we said we had a total of 7 items, and our part numbers only are covering 3. So that being the case, have the choice of renumbering, reordering, or we'll just add it to the end. Alright, so we have a 625 through, and then the 632 set screws coming in from the side. That looks more like a radius, but everything's been called out as a chamfer, so we'll go with that. And then 72 degrees, 5 places on the holes, so 1/2 inch holes. Pretty straightforward. We should be able to do that as a revolve. And then we have some choices to make on the threads. So front plane, anytime we do the revolve, center line, vertical, infinite length. Now when I bring this into the assembly, the top plane would probably have been a better choice, but we'll reorient as needed. Because the .625 is through, we want to start off of the center line some distance, and I either need to start and go up or start pretty much even to the origin and go down. So we have a stack up of numbers. Looks like a few more missing dimensions, so we'll go with what we've got, and I'm just sketching the rough shape. And the top was 1.25, so I don't want to pick that up. Alright, so I can control select the origin, and those will be coincident. We'll put in a few dimensions, so I know the bottom is 2 inches, and then a 1/2 inch for the leg. So it looks like we might be missing a right side view. The top, just kind of looking at that, doesn't look like the 2 inches, so maybe 1.5 inches. All right, so if you don't get all of the dimensions, then you get to pick those, and we'll figure it out later. All right, so 0.625. As soon as I pick the center line, I'm in diametral, and once I'm in diametral, if I'm between the center line and the object, I'm going to get radial. If I go to the other side, I'm going to get the diameter. So when I pick, I'm automatically in diametral, and now it doesn't really it's not really picking up the radial. So 1.25, and that kind of reversed. So we're going to go to the major diameter of the thread, 1 inch. And then the outside, well, looks like we have another missing dimension, so looks like about 3 inches, maybe a little bit more. Let's go 4 inches. Alright, so that being the case, and without any other details, the bolt circle, 1/2 inch on 5 holes in the bolt circle. Well, that looked like it could be 3 inches. And when the center, we did the 1.5 inches. Maybe that would be 1/2 inch or 3/8 of an inch. So pick the numbers as you go, and we will go into the revolve, and except for the 360 degrees. Alright, so the 1 inch 8 is to a depth of 1.75. So we can come up to the insert, annotations, cosmetic thread. Since I didn't pre-select, we'll grab the edge, tell it that we're doing an ANSI inch, and 1 inch 8 it found. Up to next, we want to be a blind in condition and go to 1.75. If we wanted to put in the thread class, show type. I didn't notice that. So we can do the 1" 8, and if we add the thread class, 1 is the loosest thread, 2 is the standard, 3 gets to be a really tight tolerance thread. So we can make that a 2A and go ahead and accept. So that's going to change the machine threads in our group. So the 1 3/4, and then we need a couple of holes through the top. So S key, and we'll go to the hole wizard. Oh, forgot I put the cosmetic thread on my S key. Alright, so this is going to be a through hole. We'll switch back from ANSI metric to ANSI inch, and I want to go to the filter and pick up fractional drill sizes. That'll be a little easier to find the 1/2 inch. And even with all those fractionals going out to a 64th, if you want to add or check for the show decimal values, then you can pick. And our end condition here will be up to next. So to just go through the body of the part, apply our first hole location. I'm going to do this as the circular pattern. So when I draw the circle, come immediately over to the for construction. And actually, let's undo that. Let's build this with just the circular pattern. Alright, so circular sketch pattern. We're going to have a total of 5. And if we dimension the radius and the angular separation, it's going to be 360 degrees. It switches from equal spacing to 72 degrees. And our radius can be 1.5 inches. Alright, so if I go that route, then we end up with the center lines. This is still able to kind of shift and move around in position, so I have to add the relation for the end point of the center lines back to the origin, and one of those will need to be horizontal or vertical. Now it'll get me fully defined. And I still think in terms of the base circle, but just be aware there is a second option there. Okay, so that's looking pretty good. The 632 through, it doesn't seem like that needs to be clocked in any specific angle. So if we want to try the 3D sketch again, we could go that route. Go for the hole wizard. Pick up the threaded hole. We'll rotate up until we find the 632, and up to next would stop it on the near side. Don't know that those would need to be clocked, so let's just go ahead and say through all, which will go through both walls. And if we turn on the thread class, that'll be the 2B. And we'll just see that those are a little bit different. Alright, so we place it. Notice the through all goes through the far wall, but the terminating feature is the outside of the wheel. And so if I go to the front plane and to the point, we can make that on plane. That will give it a vertical orientation, keep it from rotating around the cylinder. And then we need a dimension, and let's just see what 1/2 inch looks like. So scale wise, maybe a little bit I slipped into 2 decimal place mode, 375. Alright, so one of those two will work, and we'll go ahead and accept. Alright, so that goes through both. Doesn't look like it pulled the cosmetic thread, but the starting site is there, so that looks pretty good. And we'll go ahead and start putting in the 60 thousandths chamfers. Alright, so if I place one on the bottom as well, it kind of looks like there's one there. The intersection of the thread that's actually going to be there would have a little bit of that angle as well. So I change it to 60 and set the values. That looks pretty good as far as scale. Might be 5 inches on the diameter with a 4-inch bolt circle, whatever you want to make it. So let's go ahead and save this. And we'll come back up to the assignments, create a new folder. And this one is going to be the wheel. Alright, so optionally, if you want to go through the process with the hole wizard thread, we're also going to go through a kind of a custom thread. So in our list of cosmetic threads, if we go back and edit that real quick, and we pull for the 1/8, well, it looks like 1/8, 1/12, 1/14. Let's just say that this was an oddball side, a 1-inch 20 or something. Then we would either have to go into the database, or we would have to create a threaded swept cut for the thread. So this is the process, and mainly it's by way of introduction. If you want to try it, then go ahead and give it a shot. So open up the sketch. I don't necessarily want to convert the entities just yet. Normally if this was solid I would just convert the entities, but here I'm going to pick the outside edge, so I only get the one edge. That gives me a starter for my curve. So coming up to the curves, we're going to create a helix spiral. It needs that circle to know what it's doing. And in our choices we have pitch and revolution, height and revolution, height and pitch. So the height was the 1.75, and the pitch will be 1 divided by 20 is 50 thousandths. And then it's not going the right way. I don't want to start on a 45-degree angle, so one of my quadrants, 0, 90, 180, 270. So 0 is good. Kind of pay attention that it's pointing over to that side. No helix. Not sure why that was on, but maybe a default. We'll go ahead and accept. Alright, so that shows me the helix. And I can see that the spiral kind of comes around and terminates right at that point. So when I'm looking at the sketch, I want to draw my my thread form on the front plane. Oh, and then by habit I did the rollback above the chamfer. Mainly I know that I'm going to create an error, or I'm pretty sure I'm going to create an error at the chamfer, and then my my strategy or my my process is that chamfers and fillets typically come last. Alright, so let's go ahead and put in, if we wanted to draw the complete thread form, we could go into Machinery's handbook and look at the root and the peak, and make this a little bit more, say a little bit more complicated, closer to a real thread. So let's see, did that pick up horizontal? No. Sharp V thread is 60 degrees. And the height for the pitch is 50 thousandths, but I actually need to be a little bit under it so that the two cuts don't overlap. And then to make sure that we get a complete cut, I'm going to go to the midpoint and the curve, and we will pierce. So what pierce does, where coincident might be able to travel all the way across those that face in that plane, pierce says there is a solution on where the plane intersects the curve here, and there is a solution where the curve intersects or the plane intersects the curve here, and that's it. Coincident has a variety, or has a lot more solutions. Alright, so we could do a swept if this was a positive boss base, and then if we do a swept cut, we have the profile, and the sketch is the curve, and as it makes the cut, then we can generate the thread. Alright, so I need to go back and hide the helix, and then if I roll the chamfer forward, actually I'm surprised the chamfer was left on the bottom, but kind of see that terminating feature that we don't end up with a partial thread at the base. So to finish up, we're going to go into the file properties, and we said that we didn't have a number for this, so we're going to give it a part number, and they're fond of the ME 311 I count it. Well, we got 5 on the list, so we'll make this 6. And then the revision is A. The material, let's make this one, we'll pick it up here in a second. Material, and then finish will be just raw on the part. Alright, so material, let's make this a 303 stainless. So I got it at 304 here, so not too much difference in the 304 or 303 stainless, so we'll stay with what we have. So we should be seeing those come over into the file, and because these are set to custom, then it will be for all configurations. So like we did last time, I think I should have a threaded and a non-threaded. So the very top, we'll do the cut threads. And really the cut threads, now, you know, I could have easily made this the 120. I'm doing this more as or 1" 8. I did these as a 1" 20 for the example. And if I just change the values from the helix and the profile to 125, 1 divided by 8, I could have the 1" 8 thread. So on this group we need to suppress. And the other reason for doing the rollback on the chamfer is that since it doesn't participate or have any child relationship to the cut swept, it's less likely to generate an error after we create the suppression state. Alright, so that's ready to go into a drawing.